Well, hello and welcome to this lecture. Here we are going to understand how to declare and initialize variables. So what are variables? They are storage locations in memory with names. So let's say you have to store some data temporarily while you are running your program logic. Variables are the place to do it. So how do we declare them? So as you can see here in this example, we first have to provide the data type of the variable. In my case, it is an integer, and then the name of the variable, which conforms to the rules of the identifiers that we have gone over in previous lecture. If you want to declare multiple variables in the same line, you are free to do so. Again, you have to declare the data type of that variable and then name of the identifiers or variables using a comma separated list, as is shown here. You can also declare and initialize variables in the same line. In this example, we can see that we have a character data type variable and we are assigning it a character literal, which is t, and this is how you declare as well as initialize a particular variable. If you want to declare and initialize multiple variables in the same line, you can do this. So first of all, you again have to provide the data type, then the name of the variable, then its value, then a comma, then the second value and its corresponding value. So next we are going to discuss what are variable scopes. So the value that you are assigning to the variables, the entire code may not have access to that particular value. So it depends where you are declaring the variables, and that is what constitutes scoping. In Java, we can declare scopes in three ways. There are specifically three types. So we can have variables which we can declare at instance level. We can have variables which we declare at the class level. These are also called static variables. And we can have few variables which we specifically declare within initializer blocks and methods which are not accessible anywhere else in the class. So that constitutes local variables. So let's go over them. First of all, we are going to go over instance variables. In instance variables, we need to understand how we can declare them and what actually instance variables are. So basically, when we declare a class has its data members and it has member methods. So these data members can be a part of the object that we are going to instantiate, or it can be part of the class itself. So what is the difference? So from this class, let's say we instantiate 50 objects. So instance data or the instance members are unique to each of those objects. The instance data for a particular instance is not shared across all the objects created out of that same class. Same cannot be said about the class members or the static members. So class variables are class data members which can be accessed by all the objects created from that class. In this case, we can see we have one particular class and it has three instance data members: customer ID, customer name, and customer age. We have a constructor. I know we have not yet discussed constructors, but just for your understanding's sake, whenever we are instantiating a particular object from the class, the instance members needs to be initialized with some form of data, and the ideal place to do that is the constructor. There are of course other ways to initialize those instance data members, but for now, to keep things simple, we will do it inside the constructor itself. So this is a particular method called a constructor, and it accepts the same number of arguments as the number of instance data members we have in the class. So we have three instance members and we have three arguments in the constructor. Next thing that we do is we assign the values provided in the constructor to the instance data members. So if we go to the main method, we see we have created two instances of this class, customer1 and customer2, and we have used the constructor to assign the instance data members for either of them. Now we have an instance method as well. So what is an instance method? Instance method has ready access to the instance data, but the only catch here is you have to use a object reference or an instance reference to invoke these methods. In this case, we have created two objects of this class, and I am invoking this instance method display customer details using the object reference customer1. So we are going to discuss these things in detail in upcoming lectures, but for now, whenever you want to invoke an object method, you have to use the object reference to invoke that method. Same thing for object number 2 also, we call that same instance method, and this specifically displays the data for each of these objects. If we run this code now, we will see that we have two data sets. So since we call this method two times, one in line number 18 and another in line number 20, what we see here is we have two outputs. So the first one is the details of the object 1 that we created, and second is for the object number 2. This is customer 1 detail and this is customer 2 details. So here we see the uniqueness of instance data members. So whenever we create an object, whatever data you are assigning to that object is only accessible within that object. Customer 2 does not have any reference to customer 1 data. That is how we are encapsulating the data within the object. So we will touch upon this topic once we discuss encapsulation in our upcoming lectures. So this is the instance scope. So whenever you define or declare a particular variable at the instance level, all the instance methods will have access to that instance data member. Next, we will discuss what are static variables. Under static variables, what we can see here is the declaration has been done for 4 static members. So we have variable 1 through variable 4 that has been declared using the static keyword. So this is a point to note. Whenever you are adding that static keyword in your variable declaration, it becomes a class member. So no matter how many objects you are creating out of that class, each of those objects will have access to those static members. So what we can see here is variable 1 and variable 2, we have just declared them as static class members. Variable 3 we have declared as well as initialized it to a initial value of 100, and we have the fourth static member variable 4 that we have created a static initializer block which will assign a value to variable 4. Now static initializer block is a advanced concept, so when we will discuss class loading we will touch upon what static initializer are, but for now just try to remember that whenever we are loading the class into memory for the first time, then this block runs only once. It will not run when we try to instantiate objects of this class. It only runs once during class loading. So using this block, I have assigned variable 4 a value of 450. Now we have a non-static member as well. So all these 5 variables are class data members. Variable 1 through variable 4 are declared as static, and the last one is a normal object data member, since there is no mention of the static keyword. We can initialize them in the constructor, we can have setter methods, or we can use an instance initializer block. Instance initializer block will just start with the open brace and ends with the closing brace, and it will not have this static keyword at the start. This is what static block definition looks like, and this is what instance block definition looks like. So within the instance initializer block, we have assigned this value to normal instance variable. Now if we come to the main method, what we are trying to do here is we are trying to assign values to the static class members, variable 1 and variable 2, and in the next line we are trying to sum them up and print out the summation. Here you will notice that I have accessed variable 1 and variable 2 in two different ways. You can either prefix the name of the class to access class data member variable 1, or you can remove the class name totally, because we are accessing this variable from a static method. So the main method in its declaration has this static keyword, right? So this makes it a static method. So any static method will automatically have access to all the static class members. So that's why this is a redundant approach to prefix the class name and access the variable data. You are free to use either of these approaches. In the next line, we are printing out the value of the variable 3 and variable 4 in the same fashion. So one is without the prefix of the class name and one is with the prefix of the class name. Also, we have an object data member as well. The normal instance variable is an object data member since it does not have the static keyword. So in order to add data to this, we have to create an object first. So that's why in line 37 we have created one object, and on creating these objects, two things will happen. First of all, your instance initializer block will run, and then your constructor will run. So when the instance initializer block runs, this variable gets assigned the value of 2. So when you do a printout of that particular variable, we will see the value of 2. Now if we run this code, here we can see the summation of variable 1 and variable 2 as 50. The value of variable 3 is 100, variable 4 is 450. Then we see first the instance initializer block ran, then the constructor runs, and then in the println we get the value of 2 printed up. Next we are going to understand what is local variable. So to understand local variables and the need of declaring them, we have to understand why do we need local variables. So at the class level, whatever data members we have, it can be either static or non-static, but that will not be sufficient for all our code logic to run. We might need some data members which are not class data members, but it is still used in our program logic. So let's say, for example, we have an instance method called increment value by 5, which accepts an integer argument, a number, which will be incremented by 5 and then the value will be returned. So within this method, we see an integer declaration of increment. Now this is something which is not present at the class level. So this is neither an instance data member or a class data member. This is what is a local variable. And this local variable is only accessible within this particular method and not outside of it. Same goes for static methods as well. So in static methods, we have this declaration of increment variable, and we have used the same name just to show the scope of these two variables is different, and Java is not complaining about the clash or collision of the names, and the value of this variable is accessible within this particular method. So this is another local variable. Also, if we go to initializer blocks, so we have one static initializer blocks and we have one integer variable declared there as well, which is not accessible outside of this initializer block. Same goes for instance initializer blocks. If we have a variable declared within that, the scope of this is again within this particular block. So I have added few println statements that you can uncomment one by one and check the output. All of these four statements will error out because the way they have been accessed, it is an illegal operation in Java. Write the code, uncomment these lines of code and see what is the output. You will see that none of them will be allowed by Java. So these are what local variables. It will be accessible within the block in which they are declared and not outside of it. So that concludes this lecture. We'll see you in the next lecture. Thank you. Thanks for watching.